A transformer coupled amplifier is used in circuits where the load is small, as it's used primarily for power amplification. It also electrically disconnects the input from the output. The transformers are used for impedance matching for multiple stages. Step-down transformer with appropriate turns ratio is used so that the secondary of the transformer is equal to the load impedance, and the primary is equal to the output impedance of the transistor. As a result, we will get maximum power transfer. Now the basic operation. These base biasing resistors, when we connect power, will put these transistors into the active region. Because we've got current flow, when we've got a current flow, a change in current flow through the transistor, it will induce a voltage which will then be seen on the base of the next transistor or on the output. So depending on the direction of these coils and the magnetic fields, we will either have in phase or inverted signals. If I have an increasing input over there, that causes this transistor to turn more on. Now we must remember that for a coil, the voltage on the coil is equal to the inductive reactance of the coil multiplied by the current flow through the coil. So if I turn this transistor more on, I will have more current flow, and as a result I will have a larger voltage developing on that side over there. As a result, this transistor will receive a decreasing voltage because it is turning more off. Because it turns more off, I've got less current flow flowing through there, and because I've got less current flowing through there, I will have a decreasing voltage, and as a result, because of the inverse nature of the transformer, I will have an increasing output voltage. Conversely, if I decrease my voltage on the input, I will get a decreasing current, and as a result decreasing voltage through the transformer. That will cause a increase in forward bias on the transistor, which in turn will increase the voltage on the primary over there, and that will decrease the voltage on the secondary over there. The result is, if I have my transformer coupled amplifier, if I put a sine wave in, I will get a sine wave out, although the sizes of those voltages are dependent on the turns ratio of the transformers as well as the gain of the amplifier. The problem with the transformer coupled amplifier is its frequency response. If we look at the frequency response, we see that at low frequencies we get a low gain, and then at the mid-range we get a constant gain, and then we get to a point where we get a little pitch like that. This is my voltage gain, these are my low frequencies, these are my mid-range frequencies, and these are my high frequencies. At low frequencies, remember, XL equals 2 pi FL. So if my frequency is low, I will have a low reactance, and as a result my coils on the transformer will develop a low reactance. Because there's a low reactance, VL equals IXL. Because of my low reactance, I will develop low voltages, and as a result I will have a low gain. Medium frequencies responds very well, and then at this high frequency we get that little pitch over there. This is called my resonant frequency rise. Okay, what happens is at very high frequencies the individual loops of the coil develops an apparent capacitance. This apparent capacitance will start to resonate with the inductor's loops, and as a result we get that quick pitch in frequency or quick pitch in gain at that high frequency. As we pass that resonant frequency created by the apparent capacitance and the inductance, that individual or apparent capacitance will form a bypass condenser. As a result, what happens is, because of that capacitance, it forms a low current path. That apparent capacitance forms a low current path for current to flow through the capacitance, which is created by the high frequency, instead of through the coil. And as a result, my output frequency will, or output gain will greatly diminish.